Right, so let me explain about the second assignment briefly so that you know how to deal with them one by one. In the first question, we assume that we have two sequences. As you can see, starting from here, I typed 3 dots. It means that the sequence continues. This is very similar to the one that we showed you in the slides. And the score of PH is -2. The score of aligning P with E is -4. And for AH, we have -3. And for all the gaps, you have this penalty, -8. We don't care whether this is a new gap or extended one. All the gaps that you have, this is -8. So calculate the following. And I should use the dynamic programming for global one, okay? Because for global and local, we had different formula. Just a little difference, but anyway, it can affect your values. For F11, we have already calculated in the slides, but I've changed some values. So the value that you will find for this one maybe is different now. And that's why I start from F11. Because it was the first time I asked such a question, I showed you on the table that what do I mean by F11. But later, I don't show you, for example, what is F13, for example, then you should know. This one is F00, this one is F11, and so on. So in order to find this value, I need to have the values on the neighborhood. It's 0, -4, -8, these 3 cells. You know that in the lecture we talked about it. And as you find this one, you can either find F21 or F12, whatever you prefer. Then you should complete the whole table using the method that we use for dynamic programming. In the second question, this is very similar to the first one, but here we have dynamic programming for local sequence alignment. So in that scenario, for the row and column related to gaps, you have 0 from the beginning because we are talking about local sequence alignment. And then we asked you about these 3 cells. I didn't show you on the table because now you should know, for example, where is F11, for example. And the only difference is that in the formula, after you consider 0 for the row and column related to gaps, if you find negative values, it means that you should consider 0. Because when you find the maximum between those 3 factors, then if they are negative, then in that scenario, you should consider 0. So that's the only difference maybe. In constructing the whole table, the method is almost the same. Okay, the third question. Answer the following questions using the provided table based on dynamic programming of local sequence alignment. We had a similar picture in the slides of last lecture. And you see here, I have highlighted this path because for local sequence alignment, we usually start it from the maximum instead of going through the FMN. So sometimes I can start from here and try to trace back. When you trace back, not necessarily you will reach F00. Right? This is the case for local sequence alignment. So here I highlighted this path. Maybe this is not the best path, but anyway, this one is highlighted. So what I want you guys to do is to show me if I chose this path, then what's the sequence alignment that I suggested based on the sequences that you can see here. Okay, so write the sequence, and then you should apply gaps between them maybe in order to construct such a path. And in the item B, I asked you to maybe suggest me another path and show me the sequence again. Like, for example, show me this diagonal. This could be a good option, right? because usually I told you when I reach the same numbers, I usually prefer diagonal instead of having a gap between them. So if you go to the left or going to up, then in that scenario, it means that you applied gaps. So you should practice with it. So for item B, suggest another sequence alignment for the given sequences, which is different from the one that we showed you on the table. And please write the sequence alignment instead of providing me again a new table with a new highlighted version. If you do it, it's fine, but we don't need it. What I need is the sequence, like for example, this one. So now that you know what do we mean by sequences, as one of the students also used in the previous week, and some of you also use the same method, you put it inside the table. So it's more organized. Now that you are familiar with that, sometimes I put sequences inside the table like this. Also, we use the same in the lectures, as you notice. So I need such a thing, but here I gave you an example related to nucleotides. Here we have amino acids, okay? So what I need is the same format, but for amino acids. You can provide such an answer for item B. So if you guys have any questions, please let me know. Otherwise, I will see you on Wednesday and we will cover lecture 4.